One useful thing in any programming language is a variable. A variable, as we know from math, is a symbol that takes on many different values. But in a programming language like C, C++, or Java, a variable has a very specific meaning, and it's the name of a memory location, a storage location that contains a value. So because it's storage, we can replace the value, and that variable can take on many different values over time. Now in C, we create a new variable by writing a declaration. We declare it. When we declare a variable, we say this is the type of the variable, this is the type of the value that we're going to store in that storage location, and this is the name that we're going to use. And when the compiler sees this, it creates a storage location and big enough to hold an int, and whenever I say X, we then refer to that storage location. And here's another example with a double variable. So this is a floating point number, double grade. Grade is the name, double is the type. Notice the semicolon after each. So this is a statement, a declaration statement. Now the thing about the name, there are certain rules that we have to abide by. A name can consist of letters, either uppercase or lowercase, the decimal digits 0 through 9, and the underscore character. No other character may be used in a name. And the name must not begin with a digit. So we can't have a variable called 1x, but we can have x1. The names are case sensitive, so lowercase x is different than capital X. And in C, the ANSI standard C, names are limited to 31 characters. So here's an example of some code over here where we've declared some variables. Now the other thing about a variable, besides its type and its name, it has a scope. It's either local to a particular function, the red ones are local to the functions that they're declared in, or they're global. If I declare a variable outside any function, then that's a global variable. Okay? It can be used and seen by any function in the program. If I declare something inside a function, it's local to that function. It can only be seen and used within the code written for that function. Now you notice I have the same name, x, declared 3 different times. These are 3 different variables. This is a global variable x that holds a character. This is a local variable x that holds an integer. This is a local variable x for the foo function that holds a double value. Now when I'm in foo and I say x, this is the variable that I mean. When I'm in main and I say x, this is the variable that I mean. If I'm in some other function in the program that didn't declare its own local variable x, then that refers to the global. So when I say x in code, I have to find the closest, the most local declaration of that variable to know which one I'm talking about. So remember, outside is global, inside is local. Now let's talk about how variables are used in the LC3 platform. First of all, you may remember that I said that the sizes of different data types are specific to the platform that you're using. So in our class, we're using the LC3 platform. That's what we're going to compile to. And we're going to make these decisions that a character is 16 bits, that's one word in the LC3. An int is also 16 bits, or one word, and a double will be 32 bits, or 2 words. Now, because we have to have a storage location for each variable, we have to know where those storage locations are. So when I refer to x, I want to know where in memory is x stored. Global variables are stored in a particular region of memory, and R4 in the LC3 is going to be used to point to the beginning of that region of memory. And we're going to allocate global variables from that point up. Remember, this is up in memory, right? So we start here, and the next global goes here, and the next global goes here, and so on. For local variables, R5 is the thing that points to the beginning of our local variables. So these are the local variables for the function main. These are the local variables for the function foo. And notice we allocate them in the opposite order. So X was declared first, and it goes here, and then grade was declared next, and it goes here. Grade is a double, so it requires 2 words to be allocated. So X is here, grade starts here. For foo, X is a double, so it starts here, it's 2 words. And then ABC is an int, and it starts here. Okay? Now it may be confusing, you see 2 R5s, but whenever that particular function is running, R5 will be pointing to its local variables. So when main is running, R5 will point here. When foo is executing, R5 will point there. Okay? Globals are pointed to by R4, locals are pointed to by R5. So to generate code for accessing variables, we're either going to load from memory to a register to use the variable, or we're going to store from a register to memory to change the variable. We're going to talk about loads here, but we're always going to use LDR or STR to access a variable. Why? Because the way that we know where the variable is because of a base register. R4 points to the beginning of the global variables, and so any global variable we want to access is going to be offset from wherever R4 points. So if we want to load the global variable X, remember here, this is what it looks like in memory, so X is here. The difference between R4 and the location of X is 0, it's the same thing. So we're going to load into some register using R4, because this is a global variable, with an offset 0. To get the global variable max, we still use R4, and we give it a different offset, 1. So this loads max into R1, this loads X into R0. For a local, same thing, except our base register is R5. Because locals are stored, R5 tells us where the locals are stored. So if I want to access the integer variable ABC in the foo function, then I go to R5, and where is ABC relative to R5? -1, -2. That's where ABC is. So I load this memory location into R0. So remember, for LC3 code for variables, we're always going to use LDR or STR. Don't get confused. Don't worry about what kind of load or store to use. It's always going to be LDR or STR. So finally, I want to introduce the symbol table, which is something that's created by the compiler to keep track of information about all of the variables. So you may remember a symbol table from the assembler that kept track of information about labels. Here we're keeping track of variables. There's a little more information that we need to remember. The name, the type, so this tells us what kind of value is going to be stored in that location, and also how much memory we need to allocate for that variable. The scope tells us whether it's global or local, okay? And global is relative to R4, local is relative to R5, and then we record the offset for the variable relative to whatever base register makes sense. So R4 plus 0, R4 plus 1, locals, R5 plus 0, R5 minus 2, R5 minus 1, R5 minus 2. That's it.